Hello, and welcome to another edition of Mr. Chappell's Chemistry Screencasts. Today we're going to learn about calculating molarity and molality. What you'll learn today is how to use molarity and molality in calculations. Now, there are a couple of things you're going to need. You're going to need a calculator, a periodic table. You're going to need the definitions of molarity and molality. And lastly, I'm going to assume that you're able to calculate a molecular mass. Now, the two concentration units that we'll be using today, one is molarity, and molarity is defined as being moles of solute over liters of solution. It's a volume-based unit. Molality is defined as being moles of solute over kilograms of solvent. It's a mass-based unit. And notice the difference. Molarity, it's liters of solution. That's the solute and the solvent together. Whereas in molality, it's the mass of the solvent by itself. Let's go ahead and get started. Okay. Here are a couple of typical questions, and the first question is asking what is the molarity of 2.5 grams of sodium chloride in 1.5 liters of solution. So the first thing we need to do is let's go ahead and calculate the number of moles of solute. That would be the salt that we have. And we've got 2.5 grams of NaCl, spelled NaCl. Thank you very much. And we're going to convert that to moles, and for every 58 grams, this is the molar mass for Mr. Sodium Chloride, we get 1 mole. And according to my calculator, I get 431 moles. Whoops. Boy, today is not my day. 431 moles. And we know that molarity is going to be equal to moles over liters. Well, we've got the moles, 0.0431, and the liters of solution is 1.5 liters. And that means the final molarity is going to be 0.029 molar. And that is our final answer. Notice, in my final answer, I have just 2 sig figs, because that's all I'm allowed. The 2.5 and the 1.5 have only 2 sig figs. However, when I was computing the moles, I held on to an extra sig fig, so I don't get any rounding errors. Okay, the next question is asking, what is the volume of 1.5 moles of HCl needed to acquire 4.5 grams of HCl. So you've got this solution of HCl. You want to keep pouring until you've got 4.5 grams of just the solute. Well, the first order of business is let's go ahead and figure out how many moles we have in 4.5. Let me get the right pen here. 4.5 grams of HCl. That's hydrochloric acid for those of you in the know. And its molar mass is 36, 1 hydrogen, 1 chlorine, 36 grams of HCl for every 1 mole of HCl. And the number of moles I get is 0.0692 moles. Okay, and we know molarity is equal to moles over liters. And what I'm after is I'm after the liters. That's the downstairs guy. So let's do a little lightning fast algebra, if we would. This would be a case where cross-multiplying would actually do us some good. So I'm going to say molarity times liters is equal to the number of moles. And then, while I'm in the neighborhood, let's go ahead and divide by the molarity. I can sneak that in. And the molarities cancel. And I am left with the liters is equal to the number of moles divided by the molarity. Well, let me go ahead and put in my numbers. That's 0.0692 moles. And the volume, or I'm sorry, the molarity is 1.5 molar. And that gives us for our final answer 0.046 liters. So, in other words, you would need to pour off 46 milliliters, which isn't a whole heck of a lot. Okay, for our last problem, it says, what is the mass of CH2O, that's Mr. Formaldehyde for those of you in the know, in 450 milliliters of a 2.7 molar solution? Okay, well, let's see. We know that molarity, whoops, let me get the right pin here. Molarity is equal to moles over liters. So therefore, if we multiply both sides by liters, what I get is the number of moles is equal to the molarity times the number of liters. Well, we have both of those. And the molarity of this solution is 2.7 molar. And the volume is, well, it's got to be in liters. So I'll just go ahead and quickly do that. And that gives us a total number of moles of 1.21 moles. And this would be of CH2O. And so for our final step, all we need to do is we need to take that number of moles, 1.21 moles of CH2O, put it all over 1, and convert that to grams. Whoops, excuse me. I want moles downstairs of CH2O, and upstairs we want grams of CH2O. And for every 1 mole, we get 30 grams, the molar mass of CH2O. And let's just make sure the units cancel. And the final answer ends up being 36 grams of CH2O. And that's how you do it. Here are our last two problems. The first one is asking, what is the molality? Okay, this is a molality question of 5.5 grams of calcium iodide in 550 grams of water. So the first order of business is to get the moles of the calcium iodide. So that's 5.5 grams of calcium iodide. And just go ahead and put that all over 1. And we want grams of calcium iodide to cancel. Replace with moles of calcium iodide. And for every 1 mole, let's see, the molar mass is 294. And let's just go ahead and cancel the units. And the number of moles of solute ends up being 0.0187 moles of calcium iodide. And the molality we know is going to be moles over kilograms of solvent. Well, we've got both of those. The moles of solute is 0.0187 moles. And kilograms of solvent. Well, we're given grams, so we're going to need to convert that to kilograms if it's going to work right. And that means the molality of the final resulting solution is 0.034 molal. And there you go. Okay, for the last problem, it's asking what volume of 12 molar hydrochloric acid, HCl, will you need to produce 500 milliliters of a 1.5 molar solution. So you're using the more concentrated stuff to make something that is more dilute. And this is a dilution problem. And as we talked about in class, the equation of choice is something that looks like M1V1 is equal to M2V2, where V's are the volumes and M is the molarities. And we're being asked to solve for V1, so let me just go ahead and do that really quick. Divide both sides by, let's do this right, M1. And okay, so this cancels, and we end up with V1 is going to be equal to V2 times M2 over M1. And let me just go ahead and plug in my numbers. The ending volume is 500 milliliters. Doesn't have to be in liters. And the ending concentration is 1.5 molar. And the starting concentration is 12 molar. And you'll notice the molarities cancel, and the final unit is going to be in milliliters, which is okay. And so the final answer, we're allowed 2 sig figs, would be 62 milliliters. And that's how you do it. And that concludes this lesson. Okay, it's joke time once again. Hey, did I tell you that I went to a baseball game the other day, and I was wondering why the baseball was getting bigger? And then it hit me.